We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Namaskar friends. In this video, you will learn about the subject Basic Electrical Engineering, Unit number 2, AC Circuits. The major topic is 3-phase AC circuits. Friends, why we require 3-phase AC system? We all know that electrical power is supplied from generation end to the consumer end over a long distance by using a transmission and distribution networks. The single phase supply has the limitation for bulk power transfer as per its design. For the increased requirement of electrical power, one has to increase the size of the supply cables and conductors. But again, it will increase the size and cost of associated structures. At last, it will not be economical to increase the size of the single phase conductors for bulk power transfer for long distances beyond certain limits. To overcome this limitation, that means to supply bulk amount of power for long distances as an economical and viable solution, 3-phase supply system is required. Apart from above, 3-phase system has many advantages over single phase, which makes it attractive. Now let us compare few points between single phase and 3-phase AC systems. Single phase system supply through one conductor, whereas in 3-phase system power supply through 3 conductors. Wave shape of single phase has only one wave, whereas in 3-phase there are 3 individual waves for 3 different phases R, Y, B. Single phase supply requires 2 wires for completing the circuit, whereas in 3-phase it requires 4 wires. Single phase supply carry 230 volt as a standard reference in India, and for 3-phase system it is 415 volt. Single phase network is simple, but 3-phase network is comparatively complex. The overall losses in single phase system is considerable, whereas in 3-phase it is less. Efficiency of single phase system is less as compared to the 3-phase system. Single phase system is less economical than 3-phase system. Single phase system is mostly used in home appliances and for commercial purpose. 3-phase system is used in few residents, but it mostly used in industries to supply heavy loads. The supply structure components are less numbers in single phase system as compared to 3-phase system. The single phase type load only uses any one phase and a neutral, whereas the 3-phase load uses either 3 phases only or 3 phase and a neutral. The 3-phase type load is comparatively higher consumption loads. Now, generation of 3-phase AC EMF. It is convenient to understand generation of 3-phase EMF based on the generation concept of single-phase EMF by using a rotating vector concept. This figure explains the rotating vector. You can see in this animation, आप देख रहे हैं कि जो ये लेफ्ट हैंड साइड की फिगर है उसमें ये ओमेगा टी एंगल पे एक ऑरेंज कलर का जो वेक्टर बताया है, दैट वेक्टर रोटेट्स इन अ मैकेनिकल मूवमेंट कंप्लीट 360 डिग्री. वो जो रोटेट घूमता है, वेक्टर घूमता है, वो 360 डिग्री घूमता है. दैट इज इन मैकेनिकल. उसका इक्विवेलेंट अगर हम वेवफॉर्म दैट मीन्स इन इलेक्ट्रिसिटी में देखें तो दैट इज द फंक्शन ऑफ साइन वेव. दैट मीन्स the moment of that vector is nothing but the function of sine wave that is represented is in this circle. The quantity under consideration is the sine function of the rotating vector. The maximum value of the quantity in sine wave is nothing but the length of the rotating vector. The three-phase EMF generation concept represents by mechanical and vector arrangements. This diagram shows the mechanical arrangement of RYB windings in the generator. The right hand side figure represents the vector or phasor diagram. It is nothing but the electromagnetic waves. Each phase are 120 degree electrically apart from each other. The vector arrangement is called phasor diagram or vector diagram. The order in which the voltages in three phases reach their maximum positive value is called the phase sequence. It may be in RYB terms or may be in RBY sequence. The three-phase EMF represents by three rotating vector arrangements. Now you can very well understand from this rotating vector diagram. These rotating vectors are in motion in the space, so it is also called space vector. The waveform of the three-phase system gives clear idea about the magnitude, phase difference, frequency and instantaneous position of each phasors on a sinusoidal waveform. Now this graph is the representation of three phases in graphical manner, and right hand side is the equivalent mathematical representation of this rotating vector and three-phase waves. Now let us try to understand. On right hand side mathematically, first equation is ER is equal to EM sine omega t. This equation is for the R phase sine wave. Second one is EY is equal to EM sine omega t minus 120 degree. Now here minus 120 degree represents the time difference or lag difference between R phase and Y phase. That means Y phase will start from 120 degree of the reference R wave starting. So it is lagging behind 120 degree. EB is equal to EM sine omega t minus 240 degree. That means this minus 240 degree represents that the B phase will start after 240 degree from first start point of the R phase. Considering R phase as a reference vector, the direction of other phasors are determined for easy understanding. The three-phase supply and load can be connected in two manners. That means either in star configuration or in delta configuration. This diagram represents the three-phase star connection. In this diagram, there are three windings. First one is the R winding, red color. There are two ends of this winding, R1 and R2. Second one is for the Y phase winding, Y1, Y2N, and blue phase winding, B1, B2N. Now to form this star configuration, we have to common each individual end of this three winding, which makes a common point that is denoted by capital N, and it is known as neutral point. Whereas in a delta connection, again there are three windings RYB, but in this if we connect this delta configuration, then this R1 end is to be connected to the Y2, Y1 end is to be connected to B2, and B1 end is to be connected to R2. That means the first end of the first winding is to be connected to the second end of the next winding. The three-phase supply and load can be connected in other ways also. You can see this. This is technically connections are same as the previous diagram, but here this is the change in visual. Same way for delta connection. Now this star connection configuration is like the starfish, which is having a common point, whereas delta connection is like delta, that is nothing but the geometrical concept. General observations. The star connection have a common point called neutral. Hence, the star connection supply used for single phase type loads. The star connection supply can also be used for 3-phase type loads in both configuration. That means 3-phase 3-wire supply without neutral and 3-phase 4-wire supply with neutral. The delta connection do not have any common point. Hence, the delta connection supply is used for 3-phase type loads. Friends, if you have any query regarding these topics, you can email us on bhavin.kanani@darshan.ac.in. For more details, you can also refer our website www.darshan.ac.in.